Now let's look at how a normal distribution value is randomly generated using native Excel functions. So normal distribution is a continuous distribution. It's symmetric, bell-shaped. It's unbounded on both sides because it goes from minus infinity to plus infinity, uh, theoretically speaking. And it can have both positive and negative values. Okay. So now let's look at a particular normal distribution. Okay. So let's say that this is a normal distribution with mean of 100 and standard deviation is 10. Okay. So now again, in order to understand how this works, so we're going to look at various points on the x-axis and compute the cumulative probability. Okay, so let's say theoretically speaking, on the left end we have minus infinity, but let's start with minus 3.5, and we'll go in increments of 0.2 all the way up to 3.5 standard deviations. So we are looking at going from minus 3.5 standard deviations all the way to plus 3.5 standard deviations. So that will be our z. So the corresponding x values will be, but you take the mean, okay, let's absolute reference it, plus the z value times the standard deviation. Again, the standard deviation must be absolute referenced. So minus 3.5z corresponds with value of 65 in this normal distribution. Okay, so we have the normal distribution x values set up. Now the corresponding probability is, so now we have the cumulative probability of x, right? So let's use the norm dot dist function, right? So you provide the x value and then the mean. Okay, we need to absolute reference that. Standard deviation, absolute reference that. And then the last item is whether you want cumulative or not. So false is the default, so we say 1 for true. Okay, so that gives us the cumulative distribution of x. Okay, and less than or equal to 65 will have that probability. Now if you do this, then it goes all the way up to, so the cumulative probability of 135, okay, 135 or less is 0.9997. So you're close to the entire normal distribution. So now if you plot this, okay, we can do a scatter plot because both x and probability of x are numerical. So let's say that we want it that way. Okay. Now we need to change the x values to be that. Okay, so let's change the x-axis to go from 60 through 140. Okay, and then the y-axis to go from 0 to 1. So this axis is cumulative probability. Okay, this is the x value. All right. So now we have the probabilities. Now you generate a random probability, say rand, okay, 0.86. All right, so go to 0.86 here, traverse across to the curve and go down, you have the x value. Okay, so this is what the function will look like. Then, so norm inverse, okay, the random value is the cumulative probability, and then we have the mean and the standard deviation, and that gives you a value from this probability distribution. So you change the mean and standard deviation, then the same formula will give you random numbers from that normal probability distribution. Now if you want this number to be a round number, you can always include round around it, and round function needs how many decimal places to round. So you say 0, then it gives you random numbers.